Dear viewers, welcome to the YouTube channel H2O Chemistry. In our last few videos, we have been watching the concepts called chemical reactions happen in everyday life. So in that we have learned that we normally see chemical reactions on the basis of physical contact, catalyst, by mixing solutions, heat, electricity, light, etc. So these are the common thing we come across. So in this video, I'm going to talk about the chemical reaction based on physical contact. So there is a contact, you can clearly say, so that we are going to talk about in this video. So let us see the concept. We know that the chemical changes occurs mainly due to contact in the physical state. So when the fire contacts with the paper burns. Once paper burns, the carbon present in the paper converted into carbon dioxide and some water vapors coming out, and the last what we have is ash. So this is the product of a chemical reaction, right? So there are some other chemical reactions, the photosynthesis process, digestion, baking, and the combustion process, all are chemical changes or chemical reactions. So the combination of the reactor in naturally occurring states, it's very important. So when I talk about physical state, which means solid, liquid and gases. So the combination of reactants in their naturally occurring states is refers to as physical contact. Got it? So in their native form they combine to form new substances by physical contact. So this is an idea, my dear children. Let us go to the examples, you will understand more about this. First one, you could see the match stick. When matchsticks rubbed on the surface of the side of the matchbox, we can clearly say the rubbing produces a chemical reaction. Okay, what is present in the matchstick? The potassium chlorate and antimony trisulfate is there. When you rub with the side of the matchbox, which is made up of red phosphorus, so when these rub, slowly the fire gets generated. You could clearly say when the substance burns. What I want to ask you here is, if you make them separate, if the matchsticks here, okay, we are not rubbing, when you keep it like this, there is no chemical reaction occurs. So the physical contact makes the chemical reaction to happen. So that is what the idea, my dear children. The chemical reactions normally proceeds with the physical contact. Next example, you could see when you rub the wood continuously, it will get fire, right? It means the substance present, normally a dry wood, the carbon present in the wood burns with the help of oxygen and produces fire. Finally, it forms a products called carbon dioxide and a smoke, a little bit of water vapor too. But without rubbing, without physical contact, when you keep a lag for years, it will remain as a log, wood, dry wood, right? So what you have understood is physical contacts make the reaction to happen. Here, next example we will see. Look at this example. When the water is added to the quicklime is nothing but calcium oxide. The preparation of saccharine, this is the preparation of saccharine. So when you add it, when you add the quicklime into water, the water heats up. It's an exothermic reaction. A lot of heat will be generated. You might have seen when the white cement is dissolved in the water, immediately heat is generated. It means the white cement contains quicklime. When you add into the water, it immediately converted into slackline, which is nothing but calcium hydroxide. This calcium hydroxide reaction, formation reaction, is called slaking of lime. The product formed out of this reaction is called slaked lime, which is nothing but calcium hydroxide. This reaction is an exothermic reaction. It produces a lot of heat. Now, we have to make the physical contact, right? So, when you add the calcium oxide to the water, then only the reaction occurs. When you keep them separate, nothing happens. You could see nothing happens when you keep them separate, but when you add it, a lot of heat will be evolved and forms calcium hydroxide. So the quicklime reacts very violently with water. The new white solid is like lime. The chemical name is calcium hydroxide. So calcium oxide plus water, the product is calcium hydroxide. The next one, you could see the rusting of iron. It's a very important scenario in day-to-day life. The iron objects turn into brown in color, reddish brown in color. You could see clearly, right? So this is an idea, my dear children. Now in the April there are few red dots. In the month of May there are a lot of red dots. It means over the period of time the iron decays, or else we can say destroyed, and forms rust. That is an idea. It means the iron present in the sheet combines with oxygen as well as water vapor to form a substance called hydrated iron oxide, which is nothing but rust, which is reddish brown in color. The iron deteriorates. So once the hydrated iron oxide forms, we cannot get back the iron. So what are the conditions necessary for the rusting process? Iron, oxygen and moisture or water. These are the essential conditions required for the rusting process. Right. So the rusting of iron takes place because of the physical contact. Otherwise, the rusting will not happen. So for this, we need to understand, right? So let us have a picture like this to demonstrate. The first one, the iron rod is kept like this in a room, in the test tube. This test tube is open, the mouth is open, so it's directly have contact with the air and also some moisture. In the next beaker, the iron nail, the next test tube, the iron nail is taken along with calcium chloride, which is a desiccant we call, which absorbs moisture, and we have closed with the rubber, right? So this role of calcium chloride, it absorbs water, moisture present inside this test tube. So once all the moisture is absorbed, there is oxygen and iron, but there is no moisture, so the no rusting will form here. Come to this category. In this test tube, we have closed the test tube with the rubber as well as with the polythene sheet so that no water vapor may escape. You could see here, right? The water is here, so a lot of moisture will be there along with oxygen, and iron is here. So iron, oxygen, water vapor, so it will form rusting. In similar case, when you open it, a lot of oxygen can come. Similarly, the water vapor may go out. In this scenario also, the iron nail exposed to oxygen and water, so definitely the rusting will form in this test tube too. So the rusting forms because of the physical state. The condition for rusting is we need oxygen and water vapor along with iron to form rusting. Rusting is nothing but hydrated iron oxide. Now let us go to some activity. Now I have 3 test tubes. The first test tube I have taken some water and I have put one iron nail. Similarly, the second test tube I have taken some dry air, there is no moisture here. I have closed this test tube. After adding iron nail, I have closed this test tube with the rubber. The next one, test tube number 3, I have added iron nail and I have immersed the iron nail with water, and the top of it I have added oil. Now, what will happen to this scenario? Whether this rusting process will take place or not, we will see. In the first test tube, The ion is direct contact with the oxygen, that means nothing but air, and then water vapor. So definitely in this test tube, the rusting will happen. Whereas here, when I talk about dry air, how do I produce dry air? By adding the desiccants like calcium chloride. So when you add anhydrous calcium chloride, it absorbs all the moisture present in the test tube. So the air will be dry here. So there is enough amount of oxygen, but there is no moisture. So the rusting formation will not occur. Come to the third test tube, right? The third test tube, what we have done, we have taken few iron nails. We have added enough water to immerse the iron nails, and then we have poured some oil layer on top of it. So what happens? The iron have enough water, but the oxygen supply is not there because the oil layer prevent the oxygen dissolve in the water. So ultimately what happens? The oil prevents the oxygen, right? Transformation from liquid, right? So oil prevents the atmospheric oxygen to come and dissolve here or enter here. So in this test tube, the iron will not rust. So you could see here. So the first test tube, rusting forms. In second, no rusting forms. In third as well, no rusting forms. Now what are the conditions required for rusting is we require iron and then oxygen and a moisture or water vapor we require to form rusting. I hope this video will be very helpful in learning the chemical reaction based on physical contact. If you like this video, subscribe and click the bell button to get the notification instantly. Like this video, share it to your friends, let them learn. Comment if you have any doubt. I appreciate your comments. Thank you.